Alright, so this problem here, we're dealing with colligative properties. Basically how things that are dissolved in a liquid change its boiling and freezing point. Now the idea here is that it doesn't matter what it is that's being dissolved in the water, or whatever our solvent is. All that matters is how many particles they break into, or how many particles are dissolved in this. So it doesn't matter if we're dissolving salt, if we're dissolving sugar. All that matters is how many things will be in our solution here. So we need to figure out our concentration. And the key with these problems is not percent composition or molarity, but molality. So in this first problem here, we want to calculate the normal boiling point and freezing point of 28 grams of polypropylene or propylene glycol dissolved in the 325 grams of water. So propylene glycol is a common antifreeze. They can use it in cars. They use it if you're familiar with hockey rinks and how they work. They push it through tubes underneath the ice, so it's colder than the freezing point of water, which allows the water that makes up the ice to be frozen. So let's first, what we want to figure out is our concentration. So we have got a mass of our solute. And that's going to be 28.0 grams. And then we also have a mass of our solvent. Now the key here is to have it again in molality, and that gives us the requirement for our mass of our solvent to be in kilograms. So we're going to convert this to kilograms by using the conversion factor of 1 kilogram is equal to 1,000 grams. And this will bring us to 0.325 grams. Kilograms. Now what we need to do is convert our 28 grams of propylene glycol into moles. So we're going to take our 28.0 grams of C3H8O2 and let's figure out our molar mass. So carbon right around 12, so this is going to give us 36 for that. Hydrogen's 1, there's 8 of them, so that'll give us 8 for that. And there's 2 oxygens, that'll be 32, so 32 plus 8 will give us 40, 40 plus 36 will give us 76 grams in 1 mole. Bust out our calculator, we're going to do the division of 28 divided by 76, whoops, and that'll give us about we'll do 0.37 because I only brought my molar mass out to 2 sig figs. So I already forget what that number was. 0.37. Okay. Alright, now to find our molar mass, or I'm sorry, our molality, little m, is moles per kilogram. We're going to do 0.37 over 0.325 kilograms. That's going to be moles. And bust out our calculator again. So 0.37 divided by 0.325, and that'll give us about a 1.13, in this case just 1.1 molal solution, or moles per kilogram, using 2 sig figs because we have up here, but if you use the bigger number for your or more sig figs for your molar mass, that's fine. Now to find out our change in boiling point, we're going to need our molality plus our Kb. Same deal with our change in our freezing point, and that's going to be molality times our Kf. So delta Tb is going to be equal to our molality, 1.1 moles per kilogram, times our, let's see, our Tb up there, or our Kb is 0.52 degrees Celsius per molal. Let's say that's a 2, believe it or not. And then we're going to do 1.1 times 0.52. So it's going to give us 0.57. So that's going to increase our boiling point by a little over ½ a degree, so 0.57. So that's going to go from 100 to 100.57 degrees Celsius. And if we do the same thing for our freezing point, 1.1 times 1.86, let's see, 1.1 times 1.86, that'll give us 2.